Okay, so what I'm going to try to do is I'm going to do the examples that are posted under section 7.4, integration by partial fractions. So this is example 1. In example 1, I have the integral of x cubed plus x divided by x minus 1 dx. Well, we talked about the fact that the integrand represents a rational expression, and the degree of the numerator is more or greater than the degree of the denominator. So to simplify this expression, we can use long division. Obviously, that's the way to go. There is no way we can do this integral by using u sub. It would not work. And if we think about these other techniques that we have, really is none of them are going to help me doing the evaluating the integral. So really, when we have a rational expression, the first thing that I have to think is, how can I rewrite a rational expression? If the degree of the numerator is more than the degree of the denominator, then I just had to face long division. Now, hopefully you remember how to do the long division of polynomials. Stop by if you don't remember. Stop by my office, I mean. So here we go. I'm going to take the x to the third. I'm going to divide it by x. And of course, if you divide those two, you get x squared. Now you're going to multiply by each one of these two terms. So it will be x squared divided by x. That gives me an x to the third. I'm going to place it right here below this x to the third. And x squared times negative 1, that gives me negative x squared. So I'm going to subtract these, and because I subtracted, what I'm going to do is I'm going to change the signs here. That means I'm subtracting, okay? So it's clearer. So cancel, x squared comes down, and now it's time to bring the plus x. So again, I'm going to divide. So here it goes, divide x squared plus x. I get x. I'm going to multiply it again. 8 times x is x squared. And x times negative 1 is negative x. Okay? Remember that you're going to subtract. So I'm going to subtract, and I'm going to subtract. Subtracting a negative, just change the sign. So now I have 2x. I can still divide because of the degrees. The degrees are the same. So 2x divided by 2, I have a 2. Now I'm going to do the same thing. Multiply by each one of the terms. So that I have here a 2x, and 2 times negative 1 gives me a negative 2. Okay? Remember, I'm subtracting. This cancels, and I get a 2. So that's my remainder. So this expression can be written as, so the result of dividing x to the third plus x by x minus 1 is this polynomial right here. So I'm going to write it. The polynomial is x squared plus x plus 2. But I have these remainders. So this is 2, and the remainder is 2 divided by x minus 1. Okay? Stop by if you need to remember how to do long division of polynomials. Okay, so what do I have now? Now what I'm going to have is the integral of x squared plus x plus 2, and I'm going to separate it into two integrals so you can see what I have to do, plus the integral of 2 divided by x minus 1 dx. Okay? Well, this integral is very easy to find. That's x to the third divided by 3 plus x to the second divided by 2 plus 2x, correct? And then this second integral, to find the second integral, you are going to have to think about doing a u sub. So we're going to call u x minus 1. Obviously, the u is the x. So this will be 2 times du divided by u, which is 2 times ln of u, and of course u is x minus 1 is 2 times ln of x minus 1. So if I bring this over here, it will be plus 2 times ln of x minus 1, and of course plus c. Okay, this is a minus 1, okay, so that is the final answer for example 1. Please remember that this example is done by long division because the degree of the numerator, right, the degree of the numerator is more than the degree of the denominator. Okay, it's just that's the reason. The degree of the numerator is more than the degree of the denominator, so I can definitely do non-division.